Hi, I'm Aaron Myrick from the Aerospace Corporation, and you're listening to Firewalls Don't Stop Dragons.
Hello, everybody. Welcome back to Firewalls Don't Stop Dragons. I'm your host, Kerry Parker. As I am sure you have guessed from the introduction, we have got an interview for you today. And we're going to be talking with Aaron Myrick from Aerospace Corporation. And this is all in preparation for the Hackasat 4 contest, meaning this is the fourth one they're doing. And it's just fascinating stuff. But before we get to that, real quickly, if you have an Apple device, an iPhone, a Mac, an iPad, get those things updated. Apple has issued a patch for some actively exploited bugs. Similarly, if you have an ASUS router, that's ASUS. If you have an ASUS home router, you should be getting that updated as well. There's some bad bugs with ASUS home routers, and you're going to want to make sure you get the software updated on those as well. I did mention DEF CON. It's coming up soon. It's like 45 days away. Cannot wait. I'm all booked. I got my tickets bought, got the hotel, the flights, everything's ready to go. Even going to see a couple of shows ahead of time. It's going to be a lot of fun. If you recall, last year I partnered up with Joe from hackerboxes.com. He and I designed a indie badge. Badge life is a thing at DEF CON. Not only do the DEF CON attendees get a really cool electronic badge, but a lot of people make their own indie badges, and Joe and I worked together very hard to produce what we called the Amulet of Entropy. And I put a lot of really interesting stuff into that. I wrote the software, he did the hardware and the design, and Joe did all the hard stuff. But I did write the software for that. And if you're going to DEF CON, even if you're not going to DEF CON, HackerBox is a lot of fun. If you want to learn how to solder and do some fun electronics projects, they've got some great things. Anyway, if you're going to DEF CON and you're interested in a very cool indie badge, there are still some Amulet of Entropy badge kits left. You probably want to get it soon because it will take some time for you to put that together. It's HackerBox number 80 if you go to hackerboxes.com. Also, you can go to amuletofentropy.com just to find out more about it. I started the new Dragon Challenge Coin recipient nomination campaign, I guess, last week. I've already got a few submissions. Thank you for those who did that. I will mention it from time to time, but I'm just going to keep doing it. I'll keep it open for a while, and I'll tweak the program as needed, depending on how many people submit and what kind of stuff I get. We'll see. If you go to my website, firewallsdon'tstopdragons.com, you'll find a nice article that talks all about that. Or you could just go to fdsd.me/quest. Now, as I record this, I'm recording this introduction on Saturday. I actually recorded the interview several weeks ago. But as I'm recording this, there's some crazy stuff going on in Russia right now, so I'm not sure how that's going to shake out. But obviously hoping for a non-violent resolution to whatever's going on there. So anyway, I don't know what's going on there yet. None of us really do. So let's talk about something more fun and more concrete, and that is this Hackasat thing. So these guys from several companies have worked with the U.S. government to put together a Capture the Flag tournament, which is a hacking tournament, a hacking contest around satellite security. And obviously satellites are everywhere. There are many thousands of these things circling the globe right now. We kind of take it for granted, but they're up there doing critical work for us in our daily lives. And that's really important that we make sure that they are secure and reliable. And so in kind of a fun way, we're doing like a bug bounty kind of a thing, really, with satellite technology to try to make sure that we are getting our satellites as secure as possible. So this is Hackasat number 4. This is the 4th year they've been running this contest. And this year marks the culmination of a lot of work. And it's a really big deal this year. I'm not going to give it away now, though you may have already heard about what's going on. I will let Aaron tell us all about it in the interview. So with that as our setup, let's get to it. Aaron Myrick is a senior project engineer at the Aerospace Corporation. He's part of the Hackasat team and the lead for Moonlighter, a cyber sandbox for space systems. Thanks for coming, Aaron.
Thanks for having me on this. I'm excited to talk about all things Hackasat, space, and Moonlighter.
Yeah, well, this is the third one we've done about this. We had Jordan Wines on last year just to kind of talk about CTFs, and we had Carl Rodeo and Jason Williams on a couple years back when Hackasat 2 was a thing. That was the first time I'd heard about it, and that was actually the first time I'd gone to DEF CON, so I got a chance to actually meet a couple of those guys when I was there. That was great. So we're on Hackaset 4, so we got a lot to talk about. It's really cool what you guys are doing this year. So before we get into that, though, why don't you start by telling us a little bit about Aerospace Corp and what you do there?
Yeah, so I'm from the Aerospace Corporation, and it was a company that was started in 1960 out of concerns for conflict of interest for these companies that were building missile systems, that were starting to build space systems. So Congress mandated that a separate organization be stood up, and it's a federally funded research and development company, and we're a not-for-profit. So our primary tasks involves solving hard problems that are in the public interest. So we provide a lot of systems engineering for the Space Force, the Air Force, NASA, other civil organizations. And we really pride ourselves in being that objective voice in the noise. So we have a number of engineers that have very strong technical backgrounds. A third of our engineers are PhDs.
Hmm.
So we have a strong technical background, lots of labs, lots of interesting prototyping capabilities. One of our early projects that aerospace is kind of known for is Project 621B.
Okay,
And
what was
a lot
that?
of people know that now as GPS.
Ah,
So we were on the forefront of understanding what sort of position signals need to be sent and how to move clocks from ground receivers to space transmitters so that not everyone has to carry around a high precision clock and you could just receive it from the vehicle. We've also been involved in things like the Mercury program, the Corona program, which was an early spy program, and the space shuttle. So we've been around for a while, and we've had involvement in a lot of the space industry.
so what is your role there?
So I am a senior project engineer, is my official title, but my role typically involves working with the government or with certain projects and programs and understanding what are the hard technical problems that contractors are running into and then figuring out ways that we can solve them. We also provide oversight and sort of that validation and verification aspect of projects and programs. I started at aerospace quite a while ago, 16 years ago now.
Oh wow.
So they got me right as an intern, and I've been around aerospace pretty much my entire career, working embedded software systems, whether that's on space platforms. So satellite software is one of my specialties, and I've been involved in the cybersecurity domain for the past 12 years. So 12 years ago, we started looking at the space vehicle as an avenue where we may need to understand a little bit better to provide cyber defense of the actual satellite. And so I've been dabbling in that for the past 12 years, and it's kind of culminating in this activity with Hackaset.
All right. All right. So, yeah, we're all vaguely aware, that there's lots of satellites circling the planet and they're used for various things like global communications and, monitoring weather. We get those great satellite images of cloud formations and hurricanes and stuff. And, obviously GPS, I think most people realize that that's a satellite thing. So what are some other uses of satellites that people might not think about? What are some other ways that we depend on satellites?
So one of the interesting things that I've been able to personally work on that I think is hugely important, especially for those of us that live in Southern California, where fires happen almost on a yearly basis,
Hmm.
is we're actually starting to use our space platforms to do fire detection.
Hmm.
And we can detect when fires are starting to pick up more than just a campfire. And we can sometimes pick up those, but more than a campfire before smoke is visible far off in the distance. So we can cue off some of the fire response teams as, hey, there's a fire working its way over there. You should probably reposition your people. So that's one interesting thing that I don't think a lot of people understand. There are two systems that have started to come online pretty recently that are hugely important to the modern world. One is the automatic identification system, so AIS, This is a maritime ship tracking service.
Hmm.
And nowadays, most of those signals are collected via satellites. It used to be all on the coast
Hmm.
because they were concerned about like ports of entry, like who's
Yeah.
coming and going. But over the ocean, I mean, there's fishing that goes on, there's logistics that have to be managed, and these now we have systems in place to be able to track ships over the open ocean. And there's been some interesting work there. There's some researchers that were looking into AIS, and they were discovering these ships that kept going dark, and like they would disconnect their AIS. It's like, well, why would they be doing that? That's kind of interesting.
Hmm.
And I mean, they had their predictions, right? There's
Hmm.
probably something illegal going on
Hmm.
there because otherwise, why would you do that? And they were able to establish patterns of life using AIS. So like, oh, they're going to go dark here, so they're probably going to be in this area. And so they actually leased some time aboard an imaging satellite. So now two systems are involved here. So they have some time over this imaging satellite, and they predicted, okay, they're probably going to be in this general area. So they took some pictures, and those pictures came back, and they saw another ship that was doing illegal fishing, and they were transferring the contents
Oh,
to
wow.
the other ship that was then going to go to port and sell the legally fished items.
Huh.
So that one's just an
Yeah.
interesting story. The other one that I wanted to talk about is the automatic dependent surveillance broadcast, ADSB. This is what planes use to keep track
Mm.
of where they are. And this one has started to gain a lot of traction, especially after that Malaysian Airlines flight
Right.
went down and no one knew where it was. We were using spurious SATCOM signals to try to guess where that plane went. But this system wasn't in place at that time. So they're starting to roll out these vehicles that can collect these signals and relay them to the ground. Obviously, there's huge impact there when it comes to search and rescue, recovery of the black boxes that we still haven't found from that
Mm.
that plane crash. So we have no idea what happened there. So those are two that I think are important. Who knows what's to come in the future? I don't think we're done innovating space yet.
Mm.
We have started to see organs being grown on the ISS, and scientists think that could be a great way to have future organ donations
Hmm.
by growing them in space. And as the cost of launch is going down and it's easier access to space, hopefully that drives the cost of that down as well, and we can get organs to people that really need them. And so that's an area that I don't think we're done yet innovating. So I hope there's lots more excitement to come.
Well, and I know some people complain about they look at budgets, like federal budgets, like, oh, we're spending so much money on space, and what are we really getting for that? There's a lot of stuff that's come out of the space program and private space investments as well that have benefited us here on the planet. I mean, that would be a whole topic of discussion for a whole other podcast, but
Yeah.
it is amazing, the kind of technologies. And the other thing that always impressed me about space stuff is that it's so harsh an environment, and we'll talk about that in a little bit, but there are so many different things you've got to solve from an engineering perspective, the problems you have to solve to do this, that lead to things that you could use outside of space as well. But anyway, that like I said, we could spend, I'm sure, a whole podcast talking about that.
Oh yeah, absolutely. There's a lot to be said there.
Looking just for some statistics, because I know it's been getting crazy. Starlink and some of these other ones, there's so many satellites up there now. So do you have any idea how many satellites are up there now? And, like maybe break it down, like how much is public versus private now? Because now we've got a lot of private people launching, and like what kind of functions? Like if I had a pie chart, like like what are these things all doing up there?
Right. So right now there are around 7,900 active vehicles.
Okay.
Now there's a large amount of things that are inactive. So spacetrack.org is tracking about a little over 3,600 or 36,000 other objects.
Oh, wow.
That are man-made, that they're being tracked.
Now, some of that debris, like that used to be one object and now it's 100.
Yes, some of that is debris from various kinetic demonstrations that have been done by various countries. Some of that is still up there from when when we were first starting to explore space.
Okay.
So eventually all that does come down. Some of it takes longer depending on how far up it made it or what orbit it's in. But right now, yeah, they're tracking almost 37,000 objects in space. As far as the statistics, so the largest 3 satellite owners are all commercial. So we're talking like OneWeb, we're talking Starlink, and we're talking Planet. Those are, at least last I checked, the 3 biggest ones that are out there. Last year we had 186 total launches across the globe. Of those, 178 were considered successful. So, what's your success criteria? But 178 of those were considered successful, and that was the most that we've had to date. So it's an increasing trend of launches to orbit. Most of those, I would say, are going to low Earth orbit. So we're talking anywhere between like 100, 200 kilometers up to about 1,000 kilometers, and that's where most of the vehicles are going. And a lot of those big constellations, they're providing SATCOM, so satellite communications. That's huge across the rural parts of the world where internet access has not been available to them. I mean, who's going to run copper or fiber lines into the middle of Canada? I don't know anyone.
Right.
But we have these vehicles now that for relatively low cost can provide that sort of service. Planet, they're also a big constellation, but they're doing Earth imaging. So they provide images of the ground and on a pay-per-use service.
All right. How about country-wise? Is it what nations are putting up the most stuff?
So right now there's the big 3. I mean, there's the US, there's Russia, and there's China. Not necessarily in that order. I believe if I were to put it in order, it'd be the US, China, and then Russia.
Okay.
And so those are the big 3 people that are launching things into orbit. So the European Space Agency also has a fairly large presence, and they do a large number of launches as well, providing a good service there as well.
All right. So again, I think we take these things for granted, right? So what kind of things, and we've talked about a few, and people think, I lose GPS, no big deal. I've still got maps if I need to or whatever. But I mean, GPS is used for a lot of crucial stuff outside of just, getting your car around. So what kind of things do we take for granted that would not be possible today without satellites? Or maybe more to the point, since we're talking about cyber attacks here, like what are the real risks to our daily lives if some of these satellites were to be compromised or disabled?
Yeah, so I think it's really important not to gloss over the lack of GPS. There was a study done a few years ago about what GPS provides to the global economy, and the answer came back was $1 billion a day.
A day?
A day.
Wow.
$1 billion a day. So I think we cannot gloss over that fact. So one of the hugely important things in the modern world is precision farming. So we have these agricultural entities that have vehicles that are GPS capable, and it's been studied that they would lose their crops yield would go down if GPS were to ever go down by a significant amount. So that is a big impact on people's ability to eat.
Oh, sure, right, yeah.
So our food supply is starting to become dependent on GPS.
Well, and as you mentioned, you alluded to before, GPS is more than just about positioning. It's also about timing. And having a highly accurate, globally available clock has a lot of other weird benefits and implications that a lot of people don't think about either.
Yeah, so the stock market, the global banking relies on high precision timing. Our power grids rely on high precision timing. I'm sure there are a number of industries. I mean, when we take a reference clock in any application, whether that's communications or generating signals, our reference clock generally is a GPS clock.
Well, and security as well, right? Well, there's a lot of, at a broader scale, things like certificates and things like that we use for authentication. But your PIN code, I mean, those are time based. If your two-factor authentication codes, if you're off by more than 60 seconds, your codes are never going to line up.
Right, right, right. So yes, so GPS timing is uh, very important to us. Another thing that would impact people on the daily is our ability to do weather forecasting
Hmm.
would not be possible without space vehicles. So the reason why we're able to predict that a hurricane is going to hit the East Coast weeks in advance sometimes is we have these vehicles that are constantly monitoring the Earth and we're able to get that data back to these ground models and predict where that hurricane is going to impact. Our ability to get people out of the eye of the storm or wherever that storm is going to hit depends on space to do that.
Right.
Another aspect of life that we saw got impacted in the last few years was a certain country or certain individuals took it upon themselves to conduct an attack against KA-SAT. So they provided SATCOM services to Europe, including Ukraine, and we saw that through ground-based attacks that eventually got into the management side of these SATCOM terminals, wiper malware was deployed to these modems, and people lost their ability to communicate with the outside world. So that is another large impact on people.
Yeah, it's amazing what these things are doing for us, and most of us don't even realize it. So we're talking about cyber attacks on satellites. Satellites are thousands of miles up, potentially moving at thousands of miles per hour. So how does one go about attacking such a system, like logistically? Do you really try to communicate with and hack into the satellite itself, or do you maybe go after, like, the terrestrial ground control systems?
So I think one of the things that we have to look at is that, space system, we have to take it as a holistic thing. So
Mm-hmm.
you have your ground segment, which is typically where you do your command control, you're receiving telemetry, probably the data products that whatever that vehicle is producing, or if you're managing SATCOM, you do that from the ground segment. Then there's the link segment, which is what we have to communicate with the vehicle. So that would be our RF links, or if we have like an optical downlink, that would be part of the link segment. We have your space segment, which is the vehicle and its subsystems, its payloads. And then there's the user segment, which I don't think we should overlook. The user segment is typically the consumer of a product. So most people listening to this are part of a user segment, the GPS user segment, because they directly receive GPS signals on their phone. So everyone is a part of, a lot of people are a part of that user segment.
Sure. Yeah.
So now let's break it down a little bit. So if we just focus on the space segment for a moment here, one of the things that's hard for people to grasp is that part of the system is generally out of communication with the ground segment. So the majority of its usable life, it's not talking with the ground segment. But it still has a radio and it still receives signals. So it's like, chucking your laptop out into the world and saying, good luck, have fun. And so, from a logistics side, who are we concerned about? What are we most worried about? On the government and civilian side, I would say that it's primarily nation state actors that we would be concerned about, people that have the time and the resources to affect our systems. But we have to be real with ourselves and understand that this is a shared environment. So yes, on the government and civil side, we have the resources to put cyber protections into our systems, but we are operating in the same environment as high schools, as colleges that are launching CubeSats into the same orbit that we're going to be in. And we have to help people understand that this is a shared environment. So we need to all carry the protections that are needed.
We talk about one of the classic cybersecurity things is the CIA triad, right? It's the confidentiality, integrity, and availability. So it's a lot of people think of cybersecurity as just kind of hacking and maybe taking something over, but also making something unavailable, like a denial of service sort of a thing can have a huge impact if you're not just hacking directly or corrupting the signals. I mean, what the classic spy novel one is change the GPS signal so that when the plane is landing, it thinks it's actually 200 feet lower than it is, or whatever it is, right, to make a crash.
Right.
Are those spy novel things? I mean, like, what kind of attacks are we actually worried about? Do we have an idea of what's most likely to be the way these things are going to be affected?
So I think that's sort of what we're trying to study right now. So what we're trying to do is trying to understand what those real attack vectors would be, and then how to mitigate or work through those. We have seen things out in the open world like the KA-SAT incident, where user terminals were modified illicitly. We've also seen instances where people bounce a signal off of a vehicle as a relay. We've seen people take over television feeds. I think there was someone, I don't know if they ever found that guy, but someone in the 80s or 90s that took over HBO, I think.
Yeah, I remember that. Yeah, I remember reading about that. Yeah.
On the government side, it's a little bit different. So that what we'd be looking for is what would take the more weight on that CIA triad. So in the military aspect, availability is huge. If we're not available, then we might as well not exist. Whereas in the banking industry, you can sacrifice availability for confidentiality because there's a monetary aspect there sometimes. Like that cost benefit ratio is a bit skewed when it comes to government
sure
satellites,
Makes
military satellites versus other traditional cybersecurity things.
Yeah. If we've got a cyber attack or something going wrong, even a malfunction with a server or our network, we can go back in the server room and actually get our hands on these things and maybe get a debug port on or something. When these things are flying overhead and something goes wrong and you just stop hearing from it or it's misbehaving, how do we debug that from down here? I mean, we can't get up there. So do we ever point those the satellites with cameras at other satellites to look at them, or is there how do we debug something from down here?
Yeah, so we usually do what we call an anomaly resolution when these types of things happen. So we construct a fishbone of potential faults, potential outcomes.
And a fishbone is a diagram.
Yes. So it's a diagram, and so we're plotting out. Okay, well, if this subsystem went down, these would be the indicators of that. Or if this happened, if let's say our comm subsystem went down, our indicators would be, well, when we do a blind command, we're not receiving telemetry. Or if our power went down, we'd see these indicators in telemetry, assuming we got that back. So when we go into safe mode, which is a special mode of the vehicle, which is kind of low power, protect it, just generate power and survive. Sometimes we can pull back that telemetry to do that analysis. If a vehicle just goes completely dark, we have a hard time doing that sort of forensics and that sort of analysis. We can augment that sometimes with our telescopes or with our radar to determine, okay, is this vehicle in some sort of pointing mode? So vehicles will naturally go into a tumble state if they're not being actively commanded. So we can use our ground, either optical or radar equipment, to determine whether it's in a tumble or whether it's providing some sort of station keeping. And so that can be an indicator. And when we put all this together, and we generally come up with it's most likely this. So how do we do that from a cyber perspective? And that's one of those things that we're starting to add into this fishbone analysis is the cyber component. So what are the indicators of a cyber event? So we look at things like command counters or the command history of the vehicle. We're looking for incongruencies with sensors and with what the software thinks it has received. So stuff like that. It's still a very difficult problem though, because we can't just walk up to a server,
Right.
power cycle it,
Right.
maybe get a core dump. Oftentimes when we get into this safe mode, we're dealing with a low bandwidth situation. So we can't go into some precision pointing mode that would give us high data rate on the downlink. So we often deal with, well, what we got. So we have to reconstruct events.
Yeah, that's tricky. As a software engineer, that was something that I actually had a class I taught that I called soft skills for software engineers, and it was about all the things they didn't teach you in school with software engineering, and some of that is making something debuggable. I mean, they talk about getting your code working, but they don't they don't spend a lot of time, and it's crucial, especially in situations like yours where it's so remote and you can't just go visit the thing to, like you said, did you try turning it off and back on again? You can't do that, right?
Right.
So,
Right.
generating forensics and metrics and logs and things like that you might be able to piece together what's going on. So, yeah, how else are we not thinking about this? Like, so as an attacker, I want to understand the system I'm attacking. And so if I'm thinking about a satellite versus, an Amazon service somewhere or somebody's IoT device, how are these satellite systems fundamentally different from an attacker's perspective in terms of like hardware and software, like, because they've got to survive a launch, they've got to survive solar storms, they've got to, they're probably hardened against radiation, all this other crap. I mean, it's got to affect the overall design of the system and make it different than something normal. Or at the end of the day, does it just boil down to it's software and hardware?
Well, it is just software and hardware, but I would say there's specialized software and hardware. So two of the things that everyone that goes into space has to deal with is thermal cycling and vibration during launch. So thermal cycling can limit our choices when it comes to what sort of processors we're using. Thermal control is difficult when you can't blow air across a chip.
Hmm.
So we have to build in some thermal control mechanisms, whether that's heat pipes or radiators, into our system to accommodate that. So, and we're typically dealing with things that are relatively low power compared to what people would see on the ground. So our huge vehicles, and we're talking like school bus sized vehicles, are generating around 5 kilowatts. Our smaller vehicles our CubeSats can be, from on the range of 5 to 20 watts. And so we're talking about pretty low
Yeah.
power, but even that is a challenge to deal with sometimes, depending on your orbit. And so that's one. Vibration was the other one that I mentioned. So we can't just choose any chip off the street and put it into a board, a PCB, and launch it. There's some sort of vibration analysis that has to occur there. And a third one that some people have to deal with when we're talking satellite design is radiation hardening. So our vehicles in mid-Earth orbit and or geosynchronous orbit have to deal with that much more. At the low Earth orbit, we still have some pretty good protections with the atmosphere. So radiation hardening sometimes doesn't play a factor into vehicle design. If you're building a 10-15 year mission at low Earth orbit, then you'll probably have to deal with that a bit more than something that's only going to be up for maybe 3 years or so.
Hmm.
It comes down to how long is the design life of the vehicle, where are you going to be in orbit. Now on the software front, so when I started in the space industry, we were still hand rolling software, or we were still rolling operating system kernels, hand rolling those.
Oh, wow.
And that was only in 2006.
Wow.
So
So all custom.
yeah, it was all custom. We're starting to move more towards commercial applications. So I don't know of very many systems now that still use hand rolled kernels. Most vehicles are using some sort of commercial real-time operating system, whether that's VxWorks, Green Hills Integrity, Lynx OS. So it's starting to become a little bit more commercialized. And one of the things that has actually helped in that area is the automotive industry. So we've been taking some automotive grade hardware and putting that into orbit because it's from a vibration perspective and a thermal cycling perspective, they have to survive pretty harsh environments as well.
Huh, interesting.
And so we're kind of learning from a little bit from the automotive community because they have a significant amount of investments in self-driving cars and putting more electronics onto vehicles. So I think there's a good analog, and we're learning a lot from that community as well.
All right, cool. All right, so just you mentioned this before. Now I gotta know what is the effective lifespan of a modern satellite? You mentioned, you gave a couple ranges there, but what I'm actually more interested in is what happens when it's end of life. When that thing is done and its batteries run out or its parts run out or whatever, the warranty's out. What happens to that thing? Does it just float until it finally falls? Do they ever try to actively deorbit themselves? What happens when a satellite's useful life is over?
So a design life ranges vastly depending on what people are trying to do. So typical science experiments will range anywhere from like 1 to 3, sometimes 5 years, depending on the sort of science they're trying to achieve. Some of our SATCOM capabilities or GPS vehicles, we're looking at something around a 15-year design life for those. And when we're talking, end of life of the vehicle, we're a lot of times talking about how do we dispose of this vehicle is the term that we use in a safe manner.
Sure.
And that's largely going to depend on which orbit that you are in. So if we start at the geo orbit, so geosynchronous is the farthest out, it's over 30,000 kilometers out there. That's not coming back into the atmosphere. So
okay.
It took a lot of energy to get it up there, and that vehicle does not carry enough energy to bring it back down. So what we typically do for that is we'll put it in a graveyard orbit. So we'll either raise or lower the orbit by a acceptable amount. We'll burn off all the fuel, we'll drain the batteries, and let it go dark. And similar concept for MEO. So move it out of the usable orbit that it was in.
MEO being middle Earth, middle.
Yeah, sorry, yeah, middle Earth orbit. It's quite a big range from I think roughly 1,000 kilometers all the way up to just below the geosynchronous orbit. And then in low Earth orbit, a lot of times what we can do there is either use propulsion to bring it back into the Earth in a controlled manner, let it decay naturally, which most vehicles at low Earth orbit will decay naturally and just re-enter the atmosphere, or install a drag device. So
like a drogue chute kind of thing for space?
Yeah, so there's still atmosphere at low Earth orbit. So if you install like a parachute type of thing, it'll catch some of that atmosphere and slow the vehicle down. And as it slows down, it re-enters the atmosphere. Other things that people have looked at doing is a big piece of electrostatic tape that just kind of drags. You put a current across it, it just drags the vehicle back down into the atmosphere.
Are these things small enough to completely burn up and on re-entry? Or, I mean, the 70% of the surface area is water, so you got a pretty good chance of hitting the ocean. But what do they try to do there?
Yeah, so when we launch these days, we have to account for all the materials that we use in our vehicle and do some sort of analysis that says that this vehicle with these materials is going to burn up in the atmosphere. Now, most vehicles, even large vehicles, burn up completely in the atmosphere. The exceptions to that are sort of the larger objects in space, so those can be disposed of rocket bodies. I mean, the ISS is at some point when it does re-enter the atmosphere, there's likely to be some some objects that reach the Earth. And when we do a controlled entry, we're actually aiming for a spot in the Indian Ocean that's the farthest away from any point of land.
Mm-hmm.
So, and it's a fairly big box, but that's still what we're.
Oh my God, the news stories about people are going to be flipping out when they when they say they're going to bring that thing down, because people are going to be worried it's going to land on their head.
Yeah, and actually one of the interesting things that the aerospace does is we are actually oftentimes on news reports because we provide an orbital debris analysis for all these things. So like a couple months back when the rocket body was re-entering the atmosphere, we were tracking it all the way down, and our experts were saying, when the expected entry was going to be with, certain amount of error bars there.
Mm-hmm.
So yeah.
Well, now you said that, I've got to ask, how close were you?
Oh man, it's a good question. I don't know. I think so. We always update it, right? So it's new information. You can provide a new prediction, and so as it gets closer, you can get pretty good accuracy to roughly the time it would be. Now, there's always these weird things, not weird, but these interesting things that happen. So when there's high solar activity, our atmosphere actually responds to that by increased atmospheric activity, and so that creates more drag on these systems, and it tends to pull it down quicker. So there's predictions, and
sure.
Then there's real life.
Wow. All right. Okay. So we've laid the groundwork. We know why satellite's important. We know there's a whole bunch of them up there. We know that because they're hardware and software, they're going to have vulnerabilities. So talk to me about the Hackasat program. Why did it get started, and what were its goals? I think it's pretty obvious, but let's cover that base.
Yeah. So Hackasat we started planning for it back in 2019. We all met down in a little basement in Wallops, Virginia, in a NOAA, so the National Oceanic Atmospheric Administration. They were nice people, and we all met in the basement of NOAA and started plotting out, what does Hackasat look like? And so in 2020, we kind of had our first Hackasat, and that was impacted by COVID.
Mm-hmm.
But after that, we had a few more follow-ons. And the real goal of this is to engage this community. So we're trying to understand how people outside of the space community approach hard cyber security challenges, how they approach hard problems. And in order to do that, we kind of have to teach people how do space systems work, because it's a very complex system that's involved here. I mean, I talked about the 4 different segments, and each of those has unique specialties to them. And so part of this is we're engaging the public at large as to how we build space systems, how we have approached space systems, how we have approached these problems from a space-centric perspective. But now we're looking for people that have a cyber background, have that hacker mentality, to understand where we can get better at doing this. So that's really the main goals of Hackasat.
So okay, and to be clear, up until this point, a little foreshadowing, all the hackable equipment was sitting next to us. It was on the ground. It was not up in space, right? It was what is this? I think we call it a flat pack or something. What is the thing that these people are actually hacking, and and you do this via what we call a CTF, or capture the flag. So walk us through what up until this point, how these things have worked, and what were these things? What were these guys hacking on?
Yeah, so the competition is called a capture the flag competition. So I'm really only going to talk about the final events of Hackasat. There's a separate qualification round, but in the final events of these things, we have these teams that combine skills from multiple different areas to complete certain tasks. And that may range from breaking weak crypto to exploiting software in a synthetic way. And so that's sort of what a capture the flag is.
Okay.
And Hackasat 1, we started off just trying to create a very basic learning environment for these teams that have, by and large, not touched anything space related. So it was very much a learning environment in Hackasat 1, and they were on these hardware and software stacks. So the hardware, we called it a flat sat. So if you take a satellite, you flatten it out on the table, that's a flat sat. Typically, it's engineering models, development models, things that aren't going to be used for the flight version of the vehicle. That would be a flat sat.
Okay.
And Hackasat 2, we sort of upped our flat sat game and started putting in a little bit more realistic hardware, software, and emulation into this. And in that Hackasat, we added a user segment where the teams could interact with the other teams via the user segment. And so that was an interesting aspect of it. Last year, we did everything digital. So we pulled the flat sats out of this and wanted to do everything digital. And the reason for that is to sort of provide a more realistic emulation of what they will experience if they were to do this for real on orbit. So in that environment, we had a software stack that was on an emulated flat sat, and each team had their own satellite that was in a overall game universe, and they all got to interact and hack each other at certain points. And so that was pretty fun to watch live.
Yeah, I'll bet. Before we get to what's going on this year, what have we learned so far from Hackasat? Like, have we actually deployed any concrete improvements based on some of the things we found? Has it made an actual difference in the satellites that are up there now? And then kind of related to that, like how hard is it to patch a live orbiting satellite?
Yeah. So for the first question, what are we learning from Hackasat? So I think we kind of knew this going into Hackasat, but it was made very obvious that these are complex systems that require a team of people with diverse backgrounds to address problems. So we're talking hardware engineers, we're talking RF engineers, we're talking software engineers, and even people that are very good at space dynamics. And we have a nice joke. So the competitors, by and large, on the hacker community really hate space math, but we love giving them space math problems to solve just because it really ranks. They really do not like that. So it's really fun to give them hard space math problems. But on the security side, what we're starting to understand out of activities like this is how do we not just protect and to mitigate cyber attacks, but how to survive them, how to recover from them, what sort of indicators and warnings do we need to build into our systems such that when they do happen, or if they do happen, we're able to appropriately respond, recover, detect, and recover from that. So a lot of this is, trying to get our heads wrapped around the problem of dealing with these protections and what protections to put into place and putting them in an environment where we can play out these types of scenarios. And that's been hugely important to Hackasat. I was at Space Symposium less than a month ago, and we had a Hackasat booth. And Space Symposium is a big conference of space nerds, but also like a lot of companies go there. And there was about 5 different companies, separate companies, that came up and talked to us and were like, hey, we formed a Hackasat team. And what we did was we got our space people and our cyber people, and we put them together in a room for the qualification round. And they were actually talking to each other and kind of explaining to each other what each field's problem was. And that has been, one of those things that isn't really captured in any data that we have, but just putting these two sets of people in a room talking to each other, I think is hugely important.
Yeah.
Now, regarding patching, that's a fun one. So we typically build patching into our software structures when we're designing the vehicle. Each process, it tends to be slightly different depending on who manufactured the vehicle or who built the software. But generally speaking, we will upload the software in a binary form, little bits at a time. So our uplinks typically for vehicles are pretty small. So a lot of times it takes more than one contact window with the vehicle to upload our software. So we kind of trickle it up there into a sectioned off piece of memory. And then once we believe we finished all of that, we'll take an inventory of the software. So we're doing like a cyclic redundancy check,
Mm-hmm.
or we're doing a hash
Mm-hmm.
of what we just uploaded to make sure, did we get everything? And then once we are fairly confident that we got everything, then we'll push the patch out. And that could be to non-volatile memory, and then a reboot would occur, or we can sometimes do a live patch to live software. And that really depends on the vehicle, how it's been designed.
So back to your point, just again, because people I don't think are, got to think this through. Unless these satellites are in synchronous orbit, they're flying by. I mean, so it's like trying to talk to somebody in a car who can't stop. He's just going loops, right? So as you got to, right? You get these windows of communication time, and that they come and go.
Yeah, I like to refer to it sometimes as 10 minutes of excitement, and then 90 minutes of, or 80 minutes of just sitting back and wondering what happened.
So what's new with Hackasat 4? Because you've got some exciting stuff you're doing this year that's different from what you've done in the past. What's on deck for this year, and what sorts of things are you trying to attack, and if it's different from what you've done in the past?
Yeah, so this year we're up in our game a little bit, and we're actually putting a vehicle into orbit for this competition.
That's not a little bit. That's a big deal.
Yeah, it's a big deal. It's a small vehicle, but it's a big deal.
Yeah.
So I had the pleasure of being able to lead the team that is building what we call Moonlighter, and so what we're trying to get out of this is to take the sim out of it completely. So simulations, emulations are good only to the extent of your knowledge and your programming and your schedule to do those things. So there's always third, fourth, fifth order effects that are not accounted for in simulations. And so in this particular contest, we're going to have a live vehicle and all the challenges associated with it as part of this event. Assuming everything goes well with our launch, space is still hard, stuff like that.
So, okay, wait. So you already had some qualification stuff. So I guess I'm assuming that was not on the live things if it's not launched yet. But the finals, I think, are at DEF CON in August, right? So when is this thing going to launch?
Yeah, so we are currently slated to launch June 3rd on SpaceX 28. So that's a resupply mission for the International Space Station. So we're going up with that vehicle right now, and we'll be deployed from the space station early July, late June.
So this is kind of like a cargo situation. I mean, there are trains leaving the station with a certain amount of room, and you've got to book passage, to get on these, because it's a private thing now. They're just setting up so every so often, hey, we got room here, and you got to buy space, I'm assuming, right? So walk us through a little bit some of those logistics, because I think it's just fascinating. So if I want to get a satellite up, where do I get the funding and design and launch? And there's so many things that go into this. Just to help us understand a little bit of what that flavor's like.
Yeah, so the funding for it typically comes from, who's interested in what sort of service you're providing, whether that's venture capitalists for a lot of commercial companies, whether that's self-funded or government funded in this case. And what you need to do typically is schedule a launch about a year in advance.
Okay.
So we're going with a ride share on the way to the space station.
Ride share?
Yeah. So there
An
are
Uber.
companies. Yep, basically. So there's these companies that have contracted out their services to be integrators. So the these capsules that go to the International Space Station have space that they don't use. And so to optimize what's going up to the space station, spare space will be sold to other people. And so we got one of those on SpaceX 28, and we're going to be brought up with the food, with the clothes, with
Hmm.
the upgrades that are going to the International Space Station. And so that's sort of securing the launch, and that's outside of designing a vehicle, which is a whole engineering talk we could probably spend another hour on.
Mm-hmm.
And
Well,
then
is there a boilerplate for that at this point? I mean, you could say, look, I want a satellite with these kind of basic capabilities and this rough size. Can someone say, okay, here's a template? I mean, is it gotten to that point yet, or you're really doing every one of these bespoke?
so it depends, and I use that a lot, right? It depends. So since we're doing a prototype vehicle that hasn't been done before, there's a lot of new tech and different a different way of doing things. So this one was absolutely a bespoke thing, but as far as general vehicle design, if you're building a constellation of vehicles, yeah, you can build to print a number of them, but they still, between OneWeb and Starlink are going to have pretty significant differences, and they will still have to go through some sort of engineering process. So there's a concept design that occurs, and that's boiling down, what is it that you really want this vehicle to be doing? Because you can't have everything. There will be engineering trade-offs further down the line.
Sure.
So you
Yeah.
need to identify very early on what are the specific things that we have to have. And then based on that, you can start putting in your various subsystems that will fit those needs. You'll do a course mechanical. Okay, does it fit within a certain envelope for our vehicle? And then you move into your modeling stuff. So you're looking at power. Am I generating enough power? Do I need more solar cells? Do I have enough batteries to survive eclipse? You're doing a thermal analysis. So when you do anything in space that's not just sitting there, you will generate heat. Power generation generates heat. Power expenditures generates heat. Processing generates heat. So understanding what your thermal profile looks like in the hot and the cold cycles of a low Earth orbit is one of the trade-offs that has to be understood for the design of the vehicle. And then you go into you're building the vehicle, and that's putting together everything, all the requirements that you have laid out, both hardware and software. And then after that, you typically move into some sort of environmental testing. So this is where you've done all the thermal modeling. Okay, now we put it in a vacuum chamber, and we're going to hot and cold cycle it to make sure that everything fits that model that we have. And then we do vibration testing to make sure that, okay, if we launch this, will it survive the vibration environment that we're going to be on? And each launch vehicle has a different vibration profile depending on how you're attached to that vehicle. So for us, we were going up on a International Space Station resupply, so it's actually a nice, comfy ride. We're in a cargo bag that is, they gave us the NASA approved bubble wrap for our deployer, uh, and it's a nice soft. It's considered a soft ride for us.
NASA approved bubble wrap. Okay. All right. So I don't know how much you can give away. I'm not sure how much of this is, secret or whatever. But what sorts of things, if I'm coming into this Hackasat 4 thing and DEF CON, what kind of things can I hack? Do you have cameras? Do you have, things that are motorized? What kind of things might I be able to hack on the system?
Yeah. So because we were able to design this from the ground up, we have what we call a cyber payload on this CubeSat, and it is going to be a flight computer. So a flight computer in a satellite processes commands and handles the data that it gets from its subsystems, whether that's health and safety subsystems, or whether that's the payload subsystems. So our cyber payload here is where the activity will be taking place, and it will have the ability to impact the vehicle. Sometimes what may be considered negative, but we have the ability to shut it off and recover the vehicle in the event that things start going in a off nominal direction.
I love there's whenever you listen to space launches or whatever, I love to hear the euphemisms they use for, off nominal, or what was the one that the Starlink one where it blew up? What was the term they had for that? Unscheduled.
Sudden deconstruction.
Yeah, sudden unexpected deconstruction or something. Yeah, that just killed me. Anyway, I'm sorry. Keep going.
Yeah. So we're putting a lot into play for what Hackasat is going to be able to do here. Yeah, and I don't want to give too much into what the competitors may do, but it's going to be just like they had a real vehicle, and it will be getting actual data from orbit.
That is going to be so cool. And I'm planning to be at DEF CON this year. So are you going to be there?
I will be there.
Oh, awesome.
Yeah, primarily at the Hackasat booth. So,
I will come find you for sure. All right. So before we go, what's the future of Hackasat? What's left? I mean, is there going to be a 5 next year? And if so, what's it going to be? And how do you top Moonlighter?
Yeah, I honestly, I think Moonlighter is going to be hard to top. So I'm not sure how that's going to work. I am not exactly a decision maker when it comes to that. One of the things that I would love to see at DEF CON is, or even outside of DEF CON, is for the space industry to adopt bug bounties. So it's been a very closed off realm, both from a hardware and software perspective, but I would love to see industry-led bug bounties. So I've seen government-led bug bounties where they put up government software or government equipment, but I'd love for the industry to sort of open themselves up to people to take a good hard look at the software that they're providing people, both commercially and in the government. And I think it's doable. Yes, there are international regulations when it comes to arms control. There's export control regulations, but these are solvable problems. There's a way for companies to be able to do this, where they bring in either cleared individuals or vetted individuals to look at their software. And so I'd love to see it go in that direction.
Yeah. Yeah, it's a very. I remember when I was first interviewing for my software job, one of the managers I interviewed was a tester, and it's kind of like a hacker in the sense that you're coming at it from a very different perspective, and it's a very specific skill set. It's one thing to understand how these things work, but when you're looking at it from the perspective of kind of like a black box in a lot of situations where I got to probe it, figure out what's going on, and then I want to try to break it. That's a certain skill set that hackers are really good at. I mean, by definition, almost, right? And so and you can't grade your own homework. You need someone else to look at your stuff, right? So I totally agree. Well, this is super exciting. Can't wait to see this thing. Thanks so much for coming on the show, Aaron. That was really fun. Can't wait for this to happen in August.
All right. Thanks for having me on here. We post everything from Hackasat online. So we have GitHub repos. Our past qualification rounds are there. Our past final events are there. There's write-ups. So if people want to learn more about what we're doing at Hackasat, or generally how do I approach space problems, I think we have good resources on hackasat.com.
Well, I will actually get all that information from you and put the show notes for sure. Thanks a lot, Aaron.
All right. Thank you.
See, I told you that was going to be fun. Isn't that cool? Satellite stuff. I guess I'm an engineer, so I think all that kind of stuff is really cool. The engineering that goes into all of that is just amazing. And it's really neat that we've got an actual satellite up in orbit. And by the way, since I did this interview, the satellite was launched successfully. I actually watched it live, which was very cool. You can watch a video of that launch if you'd like. There's a link in the show notes. And currently it's on the main page for Hackasat, hackasat.com. Again, all links are all in the show notes. So anyway, the satellite did launch as part of a ride share, sort of an Uber into space. In this case, it's more like a chartered bus, because there were lots of different passengers from different other people. But anyway, went to the International Space Station along with some other stuff. And so it's waiting there to be deployed from the International Space Station. Not sure exactly when that's going to happen, but it should be very soon. And then there will be a live functioning satellite circling the globe that the contestants will try to hack into from DEF CON in about 45 days. For the patrons, I got some great extra questions with Aaron, stuff I didn't have time to get to here. I was very curious if I wanted to launch a satellite of my own, how would I do that? And there are these things called nanosats that even high schools have put into orbit. And, what does that cost? What kind of approvals do you need? Who do you partner with? How does one launch a microsatellite? Also, we talk about how you might listen to satellite signals. There's a lot of satellites up there broadcasting all the time. A lot of those signals are unencrypted on purpose, like NOAA weather satellites. I remember seeing something at DEF CON, it was last year or the year before, where somebody built a home rig for downloading images from NOAA radar satellites, the kind of thing you see on the nightly weather. There are lots of organizations out there that track all that stuff out in space. Apps you can get on your phone that will let you know when the ISS is flying overhead. But I also asked Aaron about all the space junk that's up there and what kind of problem that poses. And in particular, I asked him about the Kessler syndrome. And if you don't know what that is, you can look that up. But that is something that my patrons will be hearing about on Thursday. All right, we're already running long. Thanks, everybody, for tuning in. Take care out there. Stay safe. We got a new show for you next week and some other great interviews coming down the pike. Subscribe if you haven't. Leave a nice review for the book on Amazon or for the podcast on iTunes. I would very much appreciate it. And until next week, everybody, stay safe out there and don't get caught with your drawbridge down.